So once again, thanks everyone. I think if we talk about the future, right? I think future proving. So for me, I think the future is already here. It's just not evenly distributed, right? Especially in my view, in the world of software, I think it is a level playing field. The small can beat the large, and it's all about how you adapt and adopt, right? So from the perspective, I think this is something that everybody knows. Software is going to be the key in the digital future, right? And in my view, really, in building that software business, everything that can be optimized, right, will be optimized. And the ability to deliver software is really no longer a differentiator, right? So everybody can do that. And it is really just a basic requirement for survival, right? So it is not just increasingly an important thing. It is really the business, right? And to me, in the view, it's really about not about the big beating the small. It is really about fast beating the slow. In the world of software, I think I use apps every day. The moment the apps is not user friendly, the moment the apps is slow, the moment the apps doesn't cater to the needs for me to do anything I need to do, I literally just change, right? So software is very, very easy to change in and change out. And that's the same way that's being applied to business, right? So we can see how the e-commerce businesses are transforming, right? We used to go to physical malls, now we go to Lazada, right? So we used to go and hail a cab, now we just get a Grab, right? I've never imagined when's the last time I actually went out to wait for a cab itself, right? And at the heart of every single piece of software is the database. So I think every single user interaction itself is really powered by data, right? I think everybody knows data is really key in this whole software evolution itself, right? And what we are seeing is enterprises are really changing the way they build and run software, right? As you can see from the examples covered within this seminar itself, there is a lot of people trying to compete using software as a speed and leverage. And the way we see the market trends moving, a few key things that people talk about, literally I categorize it into three areas, right? Within the Philippines itself, everybody is talking about going fast, innovating, right? So everybody is moving towards cloud native applications. So using the power of cloud native architecture to allow them to deploy software fast, to make changes fast, and stay relevant, right? And also address the way enterprises or end users are expecting, right, with the new digital experience itself. The second wave is really about the move to the cloud, right? In the past, the whole concept of cloud is just about cost savings. Now it's no longer about that. It's really about accessibility to resources, to services on the fly, and the ability to support that software innovation itself. I think from the perspective of cloud, it is really about you're just buying a piece of mind, you're buying a piece of automation that has been done by the cloud vendors. You're buying resources that doesn't require you to wait 45 to 60 days to ship the hardware itself. So it is really about providing that resource on on-demand basis so that you can fast track the software engagement experience. Last but not least, I think there's one big revolution coming. When I change the way I build applications, definitely I need to also look at my database. So if I'm building my applications in a cloud native manner, I'm running my applications across multi-cloud, definitely the data layer also need to correspond to that strategy, because at the heart of every software is your database. So this is something that we're starting to see increasingly as everybody starts moving towards microservice architecture, everybody starts moving towards multi-cloud, everybody starts looking at resiliency, elasticity. And this is one key area that we are starting to see a lot. And last but not least, obviously the adoption of open source, right, as a underpinning innovation framework, right? So the analysts actually sort of agree to it, right? I think if you look at IDC, they said, by 2024, which is just 3 years away from here, 60% of the new applications will be built and managed using microservices and containers. So the whole concept of building microservices is not just about, it's a trend. It's really a need, because you need to innovate fast. You need to decouple the way you build, you run, you test your software, and the way you scale it fast, so that you can respond to the needs of the market. And Gartner has also said, right, 80% of enterprises will put a mechanism in place to shift to a cloud-centric infrastructure. When I meant cloud-centric, I don't mean just public cloud. It can mean private cloud, but the focus will be on automation. Public cloud vendors have given automation as a de facto. And we are also seeing on-premise private cloud trying to use automation to drive that speed itself, right? So this is something that is really happening, and everybody is trying to do that. And the reason why cloud native architecture is so popular now is because of three things. Number one, the need to run your applications anywhere, regardless of infrastructure, whether it's on premise, it's on cloud, it's on bare metal, it's on containers. Number two, the built-in resiliency of cloud native architecture. So it is meant to design to recover from failure. And in a new world itself, nobody expects their mobile banking not to work. Me coming from Singapore, I have the best experience, right? Because my national bank went down for 2 days and we couldn't do anything, right? So from the perspective, it really impacts everything from paying tuition fees to making payments itself. So this is something that people realize, right? And the gamers also realized recently because AWS went down and a lot of people couldn't access their games. So resiliency is part and parcel and is expected of any digital business, right? And last but not least, the need for elasticity, right? So in the past, when I come from in the 80s, we know exactly where we are going for, how many users, what's the workload. In the new world where you're doing B2C, I actually don't know how many users are there. I can go out and ask every single person out there. Most of the customers can't really tell me exactly what will be the exact size that they need to size for. And as a result of that, right, for any new service provision, they have to have the capacity to say, hey, I can start small and grow as and when I need, and I can scale on demand as I need. So these are the kind of characteristics offered by cloud native architecture through automation. And this is something that is really a necessity, right? In the new world where everything is on demand, right? And the way we see things evolving also is people are also moving away from how they used to build business. In the past, it's 2 databases, one for primary, one for secondary, a few web servers in front, and everything coupled together, right, with the infrastructure. Now, with cloud native architectures, we are seeing an evolution where we decouple the way we build applications into what you call microservices. They are standalone micro applications that are built and run and connected using APIs, right? And the moment I start moving from left to the center, we start seeing customers facing an issue. In the past, they run 3 databases for every applications, one for primary, one for standby, one for DR. Now, in the new world itself, one applications becomes 10 microservices. 10 microservices equals to 30 databases. 30 databases that they need to make sure they are in sync. They need to make sure they can fail over properly. And 30 databases to manage and maintain for the database team. So database sprawl itself becomes a brand new conversation as you start moving to a necessity architecture. And the whole value of microservices is they can run anywhere, they can scale anytime, and they are built for failures. So again, from the perspective of traditional databases, it is something that is pretty hard to keep up. I'll talk a little bit about how do we differentiate in terms of scaling in the new world itself. So when we look at the old and the new world, we are starting to see some differences. Think through how can you run your current database in a hybrid multi-cloud deployment itself. Think through how you're going to handle scaling, how you're going to handle cross-show. I think one thing for sure, within Philippines itself, anything that's run on the cloud is cross-show because most of the major hyperscalers doesn't exist in the Philippines, except for AliCloud. So from the perspective, literally, I'm talking about cross-geo data transfer. How do I handle that? At the same time, ensure my users are happy because they're not suffering from performance lag due to latency because the database server sits in Singapore, in Hong Kong, in India. So those are things to consider in the new world itself, right? And obviously, how do I integrate with my DevOps initiative? How do I integrate with my containers platform? How do I ensure 24/7 operations? So these are some of the key things that people are starting to realize. And these are things that should be built in by default in the new world rather than I have to go and create itself. And this is a perfect journey of one of our customers. So they were going through the same journey as everybody else. They started to go on-prem, and then they decided to go on cloud. But then they realized, hey, I have a problem scaling because there's only that big a VM I can run on my single server. So the moment I scale on demand, I need to scale my HA, I need to scale my DR. It becomes a nightmare itself. Then they move towards a NoSQL database that do scaling itself, but then they don't have the transaction consistency. So then they realize that, hey, in the new world, I really need to redefine how I look at data services. I need transaction consistency with a scale architecture and the ability to run across cloud so that I can facilitate any services for global deployment itself. And this is how they actually take on that journey of actually moving from on-prem to cloud, to a scale architecture, to a cloud-native database. And these are some of the trends that we are starting to see, right? Number one, in the new world, if I ask any developers out there, most of them are really building on open source. Open source is becoming the de facto whenever technologies are concerned. Just look at all the major hyperscalers. Every single major database services is built on open source. Amazon RDS, if you look at Microsoft, you look at Google, Postgres, MySQL becomes a de facto way, MongoDB. So open source database becomes the way for the future, not just from the technology perspective, but also from the locked-in perspective. So a lot of users are focusing on ensuring, I'm aligned to an open source database so that I do not get locked in. I can have the freedom to move around. But more importantly, the developers and the resources out there understand that technology. So it is about that now. And definitely hybrid multi-cloud becomes a norm. So as I said, the moment you have a data center here, you use AWS, Azure, or Google, you are talking about a hybrid cloud deployment, not just from the perspective of running my applications on one cloud or the other cloud, but really from the operation perspective. So operational complexity is something that every organization should realize they need to address. I can't have a set of people looking after database services on Azure and another set on AWS and another set on-prem. So from the perspective of that, everybody's looking to a platform-based approach where I have a unified experience to help me adopt hybrid cloud and multi-cloud. And obviously in the past, we tend to run active-passive. This is okay when workloads are small, but when I need to look at saving IT costs, active-passive is no longer a way to go, because one thing, when I fail over, sometimes it doesn't quite work. So the near future is all about active-active. So to make sure that they are driving resource utilization and cost savings to the maximum. But at the same time, the need to do failover will be something that people are trying to move away from. So I don't have to do DR, I don't have to do scripts to configure, I don't have to say, take time off to do that exercise anymore. If you are running active-active, that will save you all these challenges. And also, most of the applications are actually running active-active. So your users will have imbalanced experience if your database is running active-passive, whereas your applications are running active-active. And obviously, when we go to the cloud, the whole idea is when I need, I scale so that I can utilize my resource to the maximum, right? So cost savings can be achieved just from elasticity without doing anything. So this is something that is the norm for applications in the new world of cloud native. But again, from the database perspective, try imagining scaling your current database up and down for your peak hours, like your 9-9 promotions, 10-10 promotions, 12-12 promotions. This will incur disruptions. And this will definitely not be feasible for data services. But then again, so in the new world of cloud native, your data services really need to support that need for elasticity. So I can use it when I need. I can scale on demand to address peaks. I can scale on demand to address particular features that are really popular itself. And operational simplicity will also be the norm, right? So the whole idea of having a cloud-like experience, regardless of where you are, in a consistent manner, so that you can streamline security, you can streamline operations, you can manage and run your infrastructure regardless of what they are and where they sit, becomes a key focus itself from the perspective of innovation and infrastructure. And for us itself, we see borderless data will be the key norm. If you look at retail, I sell across any organizations. You look at banking, with digital banking, I do not address banking within the country, I address banking across nations. Again, from gaming, if you look at IoT, so it is really about the ability to move data seamlessly in a consistent manner without the need to think about the underpinning technology. So this is, again, one of the key things that we are starting to see in the new world of digital transformation itself. And HA definitely will be the norm, right? I will show you a few examples of what I mean. And last but not least, obviously, PDPAs. As we go into a regional embarkment for the business, we need to be conscientious, right, of data residency. So this is very common in China. Just look at DD, they had to pull out the entire business because it was a data residency issue, right? So data privacy will be key when you go into countries like Indonesia, you go into countries like China. But at the same time, you want to have a consistent user experience for all your data sets itself. So this is where Yugabyte comes into play. And Yugabyte was actually formed because of necessity. The co-founders spent about 10 years in Oracle, so they know what a good database look like, right? They work for a really good database company. And then they went over to Facebook, where they were trying to help Facebook grow in the initial years, where they're scaling their user base from millions to billions. And they realized traditional database no longer cuts it because there's only so big a server I can provision for my database. There's only so big a VM. And then I have to think about HA, I need to think about failover, I need to think about DR. So they actually co-created a NoSQL database called Cassandra. They also co-created a database called HBase to help to power the backbones of Facebook. And it's still being used now. And from the experience, they know what it's like to design a scalable database, a distributed database. And then they went over to Nutanix, where they co-developed a distributed file system that allows them to run on any infrastructure. So Yugabyte, the co-founders look at the current world itself, they look at it and say, hey, the world, as they move towards digital, they need a database that can scale in the distributed fashion so that you're not constrained by infrastructure. They also need a file system that allows you to run anywhere. At the same time, maintain transaction consistency, which is very important for almost every single segment itself. Nobody's going to say no to transaction consistency. So that's where they developed Yugabyte back in 2016. And it was actually invested by a lot of very exciting ventures like Speed, Dell, Wipro, and AVCs. So Wipro was actually trying to help customers transform, and they see database modernization as a very big arena for them. And this is what it has resulted in, a database that actually takes on a different spin when it comes to supporting modern apps. So this is how we generally grew our traditional apps. We just keep adding CPUs. And as I mentioned, there's only so much CPUs you can add. And at the same time, every time you add, there's a disruption. So most of the people will just size it for maximum, and they'll use it 20% of the time. Hopefully, things doesn't fall over. In the new world itself, it's not about that. It is about small modular database that is distributed. So it provides you with a few advantages. Number one, your data get distributed and they are redundant data. And at the same time, you just add in small increments. So as and when you need, you scale up. As and when you don't need, you scale down. And the advantage of a distributed system, it allows you to run on different infrastructure across different geographies. So it gives you the ability to scale and at the same time present as a single unified data service to your developers and to your end users. And it also allows you to put the data where the users are sitting. Imagine having a database instance serving Philippine customers, at the same time having a database instance serving the Singapore customer, but presenting as a single database itself. So as you know, latency is one of the key issues in addressing performance and user experience. And this is what a distributed system is meant to address itself, solving horizontal scalability, at the same time, latency and performance. So this is really about making data accessible, right? From powering your application for the purpose of resiliency, powering your application for the purpose of performance. So this is how we are actually creating the database for the future. So making it accessible anytime, anywhere, using a distributed approach to give you maximum performance and throughput. And how it evolved was really, as I mentioned previously, the whole idea was encompassed around, can I architect for resiliency without having to work around it? Can I handle scalability? Can I handle geo distribution with the need for ACID transactions and SQL? And this is what Yugabyte is doing. So it's trying to combine the best of two worlds, what the traditional database offers in terms of transaction consistency and SQL compliance, and what the modern NoSQL database offers in terms of the ability to do scale out. And this is how we have architected. So the founders, using their experience, create a foundation layer itself that handles self-healing tolerance, data distribution itself, no more having to do manual partitioning, rebalancing, synchronization of data, and throughput. And then they put 2 layers of APIs on top. So Yugabyte is not just a transactional database, it also supports NoSQL. So it's a combination of 2 worlds. So they decided to build the upper half using Postgres. So we're 100% Postgres compatible. So that means every single developers who are familiar with Postgres and any applications that uses Postgres can transit over to Yugabyte seamlessly. You're literally getting a Postgres++ without having to make any changes. We also have another API based on Cassandra, since they co-founded Cassandra, right? So basically, your Cassandra applications can also be transacted over to Yugabyte, having transaction consistency. So from the perspective, it allows you to address most part of your database requirements using a dual API approach. And with that, you can run on any infrastructure in a distributed fashion, whether it's AWS, Azure, Google, any container form factors that you wanted, OpenShift, Tanzu, AKS, EKS, GKE. So it becomes really, really easy for customers to modernize the way they want to run their data services. So this is another view of it. So as you go into a microservices approach, with a clustered approach, it falls in line with how your microservices are being architected, how they are being scaled, how they are being run, based on the APIs that you need. So this becomes really, really useful for any customers to address all the developers' need as they build the next generation applications itself in a very consistent manner. And this is exactly one of the feedbacks given by a very big car manufacturer as they move towards the IoT world, where they say, look, I like the NoSQL world, but I need transaction consistency. And they're future-proofing it using this approach itself. So in short, the whole idea for Yugabyte is underpinned by 2 things. Number one, the ability to run it on open source, where you can literally run it in the way you want it and pay for it when you need it. And it can run on any cloud itself. So the whole value proposition is around 24/7 resiliency, a fault-tolerant database by design, which you don't have to design around failures. Postgres compatibility for easy transition to technology. We don't want to give you a technology that you need to relearn. So using a Postgres extension layer, you literally can adopt it with minimal changes. With horizontal scalability, you can literally address elastic needs and also utilize your cloud pay-as-you-go model that you need, or in a private cloud shared infrastructure. Being geographic distributed, it allows you to future-proof your business if you decide to go regional, or if you decide to run a multi-country approach in terms of your infrastructure, utilizing on-prem in Philippines, on cloud, on AWS, on Google, on Azure. And definitely, ACID transactions and security is part of the game itself. So these are just some examples. So most of our customers are actually running multi-cloud. So you don't have to think about one cloud and then multi-cloud later on. So it's 2 birds with 1 single stone. So the database is designed for multi. So for Kruger itself, is one of the biggest retail customers in the world. They are really running their services on multi-cloud on GCP and Azure. For transaction volumes itself, we have X-Ignite that serve financial data. They're doing about 14 billion requests per day from over 100 worldwide exchanges. And for Neva, they are white boxing their retail personalization platform for Walmart and Nike. Again, multi-cloud, multi-AZ, elastic scaling. So these are what we meant by powering the next generation cloud native applications using something that's a bit different. So these are just some of the key statistics that we can show you. We can handle about less than 2 milliseconds with less than 10 millisecond writes. We are doing about hundreds of terabytes across multi-nodes. We are built for Kubernetes. So the whole idea of running any flavor of Kubernetes, we are specifically built to support a multi-AZ deployment. This is something that requires a bit of work, but with Yugabyte, it is built in by default. And we can localize data in the location that you want to. So I can deploy a database to serve multiple countries and keep data localized where I want them to. And we can survive multiple failures, even data centers. So I will show you an example later on. And definitely from the cost perspective, because of the way we're architected, we actually result in a lower TCO as compared to traditional databases itself. So these are just some of the customers and OSS, the open source users, right? So Wells Fargo, one of our customers, actually decided to move away from the legacy databases, which are spending millions, to adopt Yugabyte because it has resiliency, it has open source, it has something that the new developers are familiar with, and then they become an investor. So this just goes to show how it is in terms of confidence. In the retail space, we are serving Walmart and Google, one of the major retailers in the world. In the IoT space, we are helping to modernize their data services for 5G. Rakuten is one of our very big customers, and they're using us to build their next generation telco in a box. Then obviously in healthcare and in IoT, there is quite a fair bit of use case coming up. So this is exactly how a typical Yugabyte deployment is. We deploy as a single database across multiple clouds, private, public, in the multi-AZ deployment, in the hybrid manner where you can run as a single database in a clustered manner in AWS and to on-prem, which they can use AWS for bursting. In a single region multi-zone in the cloud itself, in a single cloud multi-region, in the multi-cloud multi-region. So literally every single combination that people are trying to envision of the way they want to utilize cloud, we support that. And we run on most of the major clouds itself. So how do I make future proving effortless? So this is the key point that we go into the details itself. So literally, I call it the power of any, right? So we talk about how do we evolve. So this is how typical cloud native workloads evolve. They move from a single app, then they start going into scale, and they realize I need to adopt another technology for scaling. And then they need to start thinking about cross-geo application because of DR or global users. And Yugabyte itself allows you to adopt that by being a cloud native application. So we allow you to scale out, we allow you to run globally distributed, we allow you to run it in a transaction consistent manner as expected of your traditional databases. So you don't have to compromise on transaction consistency for the purpose of scaling and cross-geo deployment. So this is a perfect example of how we work hand in hand with distributed technologies. Hasura basically is a distributed technology for GraphQL. And basically, in that sense, we allow Yugabyte to scale in tandem with Hasura. So this can be your Kafka clusters, this can be your GraphQL clusters. The whole idea is your data layer is distributed. Your database also need to follow that so that you can maximize the transactions and the throughput for every single node. And you can scale according to your data layer itself. So this, and then they can connect to any node and they can add and remove any node at any time in tandem, in similarity to the way you scale your applications, your new data services itself, whether it's API, whether it's streaming, whether it's GraphQL. And that's another customer trying to find an easy way to move to a cloud native architecture. And all we need to do, if you are running on Postgres, just export, import, right? pgdump over to Yugabyte, and there you have a cloud-native database with the ability to distribute your data and run on any clouds without you having to compromise anything. Any workload itself. So again, from the perspective, these are some of the common use cases that we are seeing. Cloud-native workloads, people who are trying to adopt microservices to modernize their database, people who are trying to run multi-region, multi-cloud, especially in retail, in gaming, in remittance, in the payment gateway industry, people who are looking at IoT and streaming to support fraud detection, financial market data. So these are just some of the examples of smart vehicles. And this is a perfect example where we literally allow Nava, one of our users, to move to a distributed SQL because they keep worrying about their business being too good and they can't scale. So basically, we are helping them handle about 125 million unique users with 6 billion data ops per day, and the ability to scale on demand, on peak periods, and scale down when they donate it with resiliency built in on any cloud. So they allow them to utilize any cloud facilities, right? Whether they want AWS, Google, or Azure, and allow them to move from cloud to cloud and deploy on any cloud locations without having to put times and hours making sure things work. So Yugabyte really simplify that cloud experience in terms of the data layer in any scale, right? So scale out when you need, scale down when you need. There's no artificial limit. So everybody who's looking at Amazon Aurora, they actually have a maximum 96 vCPU limitation itself. So with Yugabyte on the scale architecture, literally, you don't have that constraint and you can run on any location that you need to. And this is just an example of how fast or how big we can grow, right? 1 million transactions per second, no problem. 100 TB of data, no problem. 2,000 vCPUs in a single cluster, no problem. So literally, we allow you to scale in the way you want to scale without you having to constrain yourself in terms of architecting it, making sure things work. And these are just some of the scaling mechanics that you see. Literally, it scales almost horizontally, right? You can see the scaling is quite seamless itself. What about anytime? So really, I think in the new digital world, uptime is money, right? So how do you protect your database from the cloud? So cloud is not infallible, right? So this is just the latest, right? So gamers doesn't have access because AWS goes down and the outages takes down banks, right? It may not be a problem of the cloud vendor. It could be a problem of networking, right? So Texas winter storm, it takes down the Azure cloud service. And and at the same time, you also need to think about upgrades, right? So the moment we talk about legacy upgrade, we need to do promotions, we need to do manual interventions, we need to make sure things get failed over properly. In a distributed SQL, everything is automated. So there is failure survival without any manual efforts, right? So the RTO is literally 3 seconds with no data loss. So again, this is something that you don't have to architect around it. It is just built in. And this is a perfect example of what I meant by a resilient architecture. So this is one of the major retailers where they have 3 data centers sitting in the US itself. And it supports about 100 million items with billions of mapping and about 100,000 queries per second. And during the Texas winter storm, one of the Azure data center literally goes down, right, because of the power outage. And the users of their catalog application doesn't actually have any impact at all because Yugabyte is has built-in resiliency because of its architecture. So the other 2 data centers actually picks up the workload. And there is no loss of service, there's no loss of performance, there's actually no loss of quality to the users itself. So again, this is something that every single organization is trying to do. How do you make resilient effortless, right? So I think this is, again, one of the key things that we are helping our customers with. And obviously running it from anywhere, right? So in Philippines itself, of course, is the ring of fire. So there's always a need to say, hey, how can I protect my applications, right, in a very resilient fashion? So they can, if you can adopt a hybrid approach using a public cloud vendor in Singapore or Hong Kong, at the same time using your data centers, it will be seamless, right? So with Yugabyte technology, it allows you to do that. So it allows your data to sit near where the users are staying. At the same time, it allows you to utilize the capacity of cloud vendors. It allows you to make data where your users are actually closest to. If you are addressing, for example, your Philippine community in Singapore, so if you're running a bank, so with Yugabyte, you're running one instance in Singapore, another 2 instances in Philippines. So you're actually serving your users from 2 sides of the equator where the data sits close to the application, and their performance and the user experience will be seamless. But more importantly, with the ability to localize data, you can ensure GDPR compliance for most of the countries itself without having to work around it using manual efforts or third-party tools. So this is how we can address resiliency, right, and performance and compliance with the different abilities of Yugabyte, right? So we support synchronous and asynchronous replication itself. So you can choose performance and consistency based on what you need. So this is a perfect example or a typical example of how we deploy Emerald, which is really helping to serve a lot of internet companies. They are actually deploying Yugabyte across the globe, which they never have to down their applications, and they're addressing all those requirements with less than 5 milliseconds latency globally. So literally, we can bring you global from the applications without having to work around it. On any cloud, obviously, Yugabyte is built to support most of the major technologies out there. So Tanzu itself, GKE, OpenShift, Amazon ECS, Amazon EKS. So all these things are literally no issue for Yugabyte. So you are able to deploy in the way you want to deploy. And we have actually benchmarked ability to run on mono cloud and dual cloud. And these are the response that we get. So we are actually performing just as good or even better on the dual cloud configuration itself. So literally hybrid cloud, multi-cloud becomes a non-issue for you itself when it comes to Yugabyte. And most important thing is I want to pay for what I need, or I want to use it if for free if possible, right? So we have 3 versions in Yugabyte. We believe we need to address the community. So we have a 100% open source community version that you can use. It is 100% full featured that you can download and manage by yourself. The only thing is obviously everything that we say are working comes right out of the box. You just need to do your manual infrastructure operations and manual day too. And we have our enterprise version, which we put the layer of automation on top. So it allows you to easily monitor provision across multi-cloud and create database as a service. So this is one of the most common model that's used by our customers. For customers that really doesn't really want to manage database, we also have a SaaS model, which we offer on public cloud vendors like Google, Azure, as well as AWS. So you just pay for it, you will manage it, you will upgrade it, you just consume it as a service itself. So this is exactly how it looks like in the new world of database. You can choose the way you want to run it, how you want to deploy it, where you want to see it, and literally telling you how much it's going to cost and how you're going to deep dive in to look at everything else. So to sum up, I think Yugabyte itself is really meant to address the new world itself. For OLTP and hybrid transactions. If real-time transaction experience is important to you, data criticality is important to you, mission critical is important to you, this is something you can consider itself. So there's a lot of use case. You can feel free to reach out to us. So I sum it up by saying, look, if you are looking at the new world, so this is one potential thing. You don't literally have to pay for it. You can use the open source version and try it out for yourself.